Today we are talking about graphing linear equations in standard form. We want to be able to answer these two questions. How can you describe the graph of an equation, ax plus by equals c, and how can you visually represent the graph of the equation, ax plus by equals c? Alright, standard form is just when you see a coefficient multiplying your x and a coefficient added to a coefficient multiplied your y equals c. You can see that right here, ax plus by equals c. A and b cannot both be 0, but one of them can. There are a couple of different ways to do this. I'm going to show you two today. The first thing we can do is we can get it into slope-intercept form, which is also called y-intercept form sometimes, and then we can graph it from there. So to get it into y-intercept form, we want to get y alone on one side of the equal sign. We need to use our inverse operations in order to do this. Since we have negative 2x minus 4y equals 12, we want to move negative 2x first. So we add 2x to both sides because the opposite of negative 2x is positive 2x. Then we have negative 4y equals 2x plus 12. Next thing we want to do is get rid of that negative 4 that is multiplying our y. So the inverse of multiply is divide. We're going to divide by negative 4, and we get 1y equals 2 divided by negative 4 is negative 1/2, and 12 divided by negative 4 is negative 3. So we can now graph this equation. We start with our y-intercept. This here is our y-intercept. And this is our slope. Using those two things, we can graph this. So we start here with our y-intercept. Our y-intercept always goes on our y-axis. We go to negative 3. So our y-intercept is now graphed. Now we need to graph our slope from our y-intercept. So it's negative 1, 2, or 1, negative 2. They cannot both be negative, but one must be. So if I go up 1, I need to go negative 2. If I go down 1, I need to go positive 2. So we can graph this line. See how straight I can draw this line. That was pretty good. All right, so this is the line, negative 2x minus 4y equals 12. Or we could also label it y equals negative 1/2 x minus 3. The next way we can graph these is by choosing our x's, solving for our y's, and graphing those ordered pairs. So if I choose my x's, all right, I am going to choose 0, 3, 6, negative 3, and negative 6 for my x's. And the reason I picked choosing multiples of 3 is because I'm going to have to divide by 3 to get that 3 away from my y when I solve for y, and I don't want to have to deal with fractions. So when I plug 0 in for x, I get 0 plus 3y equals 6. So we have 3y equals 6. We divide by 3 on both sides, and we get y equals 2. So when x is 0, y equals 2. When we have 3 for x, we have 3 plus 3y equals 6. We subtract 3 on each side, and we get 3y equals 3. Divide by 3, and we get y equals 1. So when x equals 3, y equals 1. I'm going to have to erase here to have room to solve for the other x's. All right, so when I plug in 6 for x, 6 plus 3y equals 6. We subtract 6 on each side and we get 3y equals 0. Divide by 3 and you get y equals 0. So when x is 6, y is 0. When we substitute negative 3 for x, we have negative 3 plus 3y equals 6. Add 3 to both sides. We get 3y equals 9. Divide by 3 and we get y equals 3. So when x equals negative 3, y equals 3. Then when we substitute in negative 6 for x. We have negative 6 plus 3y equals 6. We add 6 to both sides, and we get 3y equals 12. Divide by 3, and y equals 4. So, when x is negative 6, y is 4. So let's graph these. We have 0, 2. We have 3, 1. And we have 6, 0. Then we have negative 3, 3. Negative 3, 3. And negative 6, 4. So we connect those plotted points, and this is our line, x plus 3y equals 6. So I think we've answered these questions. We've been able to describe the graph of those lines. Those lines are going to be straight lines, and we've been able to visually represent them by graphing.